Somebody's got a phone thing. All right, so number 1. It says to factor. What is the very first thing I need to do when trying to factor? Anybody? Look for a greatest common factor. Please, whoever has that, turn it off. I'm glad you like birds, but... Okay. Greatest common factor. So we take a look at the coefficient between 8 and 24. Start with your smallest number. Is 8 a factor of 24? Yes, it is. So we can divide by 8. I have y squared then, and y to the first power. What am I going to divide by since I do have y in both of them? Y to the what power? The smallest exponent, right? So this would be y to the first, which is just 1y. And then I have z and z to the fifth. So the smallest that is common to both is going to be z to the first. All right, now what you have just found is the greatest common factor. And we rewrite that out in front, okay? But we're not done. When we factor, it says this greatest common factor times what gives me my original problem. So then we need to look at this division. So 8 divided by 8 simplifies to 1. Y squared divided by y to the first. You are subtracting, so that is y to the first. And z to the first divided by z to the first, that simplifies out to be a 1 also. So from that first term, all I have left after dividing this out is y to the first. Minus 24 divided by 8 is 24 divided by 8, 3, yes. And y to the first divided by y to the first, that's going to simplify out to be a 1. Z to the fifth divided by z to the first. What is that going to be? Z to the... Jamarian, what's that going to be? Can't hear you. Z to the fifth divided by z to the first is going to be z to the fourth. Because when you divide powers that have the same base, you subtract. Okay? So this right here is the factored form. This part in front is your greatest common factor, and what you have left after you divide is the second whole factor. Okay? Questions on that? We really need to become comfortable with this. Desmond, are you with me? Okay. Let's take a look at number 2. All right. Oh, right away you're like, hey, there's a difference. These look like a difference of 2 squares. But I will remind you, what do you always need to look for first? A GCF. Because that makes your problem simpler when you can factor something out. So I have a 4 and I have a 36, Emily. 4 and 36, okay? Is 4 a factor of 36? Yeah, so divide by 4. Divide by 4. This has an x squared. Does my second term have any x? No, so you can't factor out something that's not there. So this is the greatest common factor. The 4 comes out front, but wait, we're not done. It's like that commercial, but wait, there's more. So you've got 4 divided by 4 simplifies to 1. I have an x squared minus 9. Then hopefully you look at this and you say, hey, this looks like it could be a difference of 2 squares. So I could rewrite 9 as what times what? What whole number times what whole number? Yeah, 3 squared. So I can rewrite that so I actually see a difference of 2 squares. And I would really like to see this. Do you have to show it? No, but it easily says this is a perfect square and this is a perfect square. So then I look at these two bases. The 4 still comes out in front. And I rewrite it as my base that's squared in front plus my base here, so x plus 3 times x minus 3. Because whatever those bases are that are squared, they become your first and last terms in each problem. Are you okay? Okay. So there it is. That is the factorization for that problem. Questions on that? Is that one getting a little bit easier? But you got to recognize if you have two terms with subtraction sign in between, you need to maybe go another step. Can't always just go one step there. All right, let's go to the trinomial. Sometimes these are the most difficult, okay? Greatest common factor. Do I have one? What's my coefficient in front of the first term? 1. Whenever you just have 1, its only factors are 1 and 1. That is not enough to take out as a greatest common factor in doing this part of it, okay? So right away, I don't have a greatest common factor. You need to go to X box. All right? So you need to ask yourself, what's my A value, what's my B value, and what's my C value? So give me the A. 1, yes. Give me the B. Yorn, what's my B value? Yes, good job, Yorn. You're a ventriloquist. That's all right. And how about the C? Negative 24. At the top of this goes our outside amounts. A times C, that's negative 24. And at the bottom is your B value. So two factors that multiply to give you a negative, that means one has to be positive, one has to be negative, and add to give you 5. Now, excuse me, I see people doing this, but they'll maybe stop after 2 factors. You have to go through the whole gamut because there's 3 times 8. There's 4 times 6. So you can't just stop after a couple. All right? Okay, so this is positive. That means my largest number is also positive. So all of these are positive, which means since I have a negative product, a negative answer, these have to be negative. So which of these pairs add up to 5? Negative 3 and positive 8. Now, A is equal to 1. This is a nice little easy, it's not a trick per se, but it kind of is. Since my first term is x squared, the only thing that would multiply to give you a 1x squared is 1 times 1, which means these here are part of your factors. So since we're dealing with x, it's going to be x minus 3 for that first factor, and x, since this is a plus 8 or positive 8, plus 8 over there. And that's it. That's it. If I do this in my head with double distributive property, x times x is x squared, x times 8 is 8x, minus 3x gives me 8 minus 3 is 5x, and negative 3 times 8 is negative 24. That's how you can check quickly in your head, if you want to. Okay? Questions on that? Do we understand that only works when A is equal to 1, though? Shake your head yes. Or no if you don't get it. Dana? Yeah? Okay. Charles? And A is equal to 1. When you do this X part, right there are your factors. All right, let's go to the last one. Pay special attention to this one. So, first of all, GCF, do I have one? Survey says no. We have 2, but 2 does not go into 7 evenly. It does not divide into evenly. So right away, with 3 terms, I know I go to X box. We have A is equal to, what's A equal to, Narek?
You said what?
What's A equal to?
3.
3, good. B is equal to, Luis, what's B equal to?
7.
Good. And C is equal to what, Camille? 2. Excellent. A times C at the top, these outside terms. 3 times 2 is 6. The bottom is B for 7. 2 factors of 6 that add up to 7. There's only one answer that's going to work if this answer happens to be bigger than your number itself. It's got to be the number itself and 1, right? Bless you. So then we go to the box, Rihanna. We go to the box. Rihanna, are you with me? Okay. So first term, whole first term goes in the first box. Last term goes in the last box. And to get that 7x, we use the 2 terms that we found here, 6x plus 1x. Yes, you do need to add the x there, okay? And then you're just looking for greatest common factor of each row and column. And Desmond, this is something I wanted to point out. You really need to keep them in this order and try to go to the left. I saw you doing it over here, but you just got to be really careful of your signs then, okay? So a 3 and a 1, if you have a 1 and you have to factor out something, 1 is going to be your greatest common factor, okay? Then you have an x squared and an x. You can only take out an x to the first from both of them, right? 6x and 2, start with your smallest number. Is 2 a factor of 6? Yes. That's a positive 2 because this is positive. And this one has no x, so I don't need an x there. Looking at my column, 3x squared and 6x, I've got a 3. Is 3 a factor of 6? 3 times 2. So 3 is a factor. You got an x squared and an x, so you're going to factor out an x. You will always have an x here and an x here. Always. And in your last term, you shouldn't have any x's. You got a 1 and a 2. It's a positive 1, so it's going to be plus 1 here. Finally, you really need to write these out and show me these are the factors. These are the 2 terms that we multiply to get my answer above. Questions on that? Yeah, all done? You can just put it down or take it into the bin on my corner. Okay. Are we feeling a little better about factoring in general? A little bit? Okay. Well, good, because we're going to be doing even more now. Woohoo! All right, so open up your notes, please. And I wish I could tell you what page, but if you remember, we don't have page numbers. So this is what you were supposed to look at yesterday. Not yesterday, 2 days ago on Wednesday. Using the square root principle, I'm just going to show this to you very quickly. And the notes you can copy down the notes. I suggest you copy down the notes. All right? I'm trying to figure out which one I want to do. I think this one. I'll do this one again really quickly. So let's go. I don't know what page this is. And if you did it, great. We'll just solidify it some more. It's the top of maybe page 4, the 4th page in. Says quantity x minus 2 squared equals 16. Both of these are perfect squares. These are perfect squares. Okay? This I know definitely is a perfect square because that's got a 2 in the upper right-hand corner. And 16 is also a perfect square because 4 times 4 equals 16. So if you have 2 perfect squares on either side of the equation, we are going to do what it says over here by using the square root property. Okay? So if you have a perfect square and you take the square root of it, you make the little square root symbol, which has a little, kind of a little V there and a kind of little V there. All right? When you take the square root of something that is squared, Charles, what you have left is simply the base that's in the inside. So that means x minus 2 is no longer squared. That is your base. And that is equal to the square root of 16. We know it's a positive 4, but what we also need to remember is that it can be negative 4, because negative 4 times negative 4 gives you positive 16. Okay? So we are trying to solve for x here, because now we are dealing with equations. So we want to isolate and get x by itself. So I am going to add 2 to both sides. Okay? So x is going to end up being 2 different answers. I'm going to take the top answer first. So that means the positive 4. So this was positive 4 plus 2. And x is also equal to the negative 4, the bottom part, negative 4 plus 2. So when I substitute that in, I get x is equal to 6, or negative 4 plus 2, x is equal to negative 2. Those are your 2 answers. What does that mean if I substitute these back in? Well, let's take a look. If I substitute 6 back over here, I get 6 minus 2, which is 4, and 4 squared is 16. If I substitute negative 2 in, negative 2 minus 2 is negative 4 squared. Negative 4 times negative 4 is 16. So they both work. So if you have a perfect square on both sides of the equation, take the square root of both, and that gives you your answer. Okay? I strongly recommend, if you did not on Wednesday, watch the video, copy down the notes. But we've got to move on. All right. Homework number 1. Does anybody else have that done yet? Okay, make sure we're working on that. This is extremely important. I want you to put asterisks, asterisks, box it, underline it. It is very, very important. Before you can solve an equation, and the key word is equation by factoring, the equation must be equal to 0. So factoring before, what we did in our examples, that was all expressions. There was no equal sign here. Now we need to set it equal to 0. Okay? So here's our first problem. 4x squared minus 12x equals 0. Okay? That's kind of a check mark. Yes, it's equal to 0. And then we just go through the same paces. Do I have a greatest common factor for these two terms? Well, check your 4, check your 12. Is 4 a factor of 12? Survey says yes. So you're going to divide by 4. You have an x squared and an x. X to what power are you going to divide by? X to the, not third. This one only has 1, so it's 4x, x to the first. This is your greatest common factor, so factor that out front. 4x, and then what do we have left? So let's divide. 4 divided by 4 simplifies to 1. X squared divided by x is x to the first, right? Minus 12 divided by 4 is 3. And x divided by x simplifies out to be 1 times 1. Equals 0. Okay? Now, these are my two factors. So I need to set them up to be 0. Because if you have something times something equals 0, that means either this has to be 0 or the second factor has to end up equaling 0, right? If something times something equals 0, either this is going to have to be a 0 in that term or that's going to have to be a 0. So we set the first factor, 4x, equal to 0. We're going to see what does x have to be if that first factor is 0. I'm solving for x, so I divide by 4. Divide by 4. 4's cancel out. X is equal to 0. So when x is equal to 0 for this first term, that's going to make that equation true. Let's see what we do for the second factor. X minus 3 is equal to 0. So add 3, add 3. 3's cancel out. X is equal to 3. What does that mean? Yeah, when you substitute 3 in for this x, 3 minus 3 is 0. That makes that term, that factor 0. And so, yes, that will give you 0. So the answer is x is equal to 0. Or, and I keep putting and, but the correct terminology is or, x is equal to 3. Those two answers will make it true that this up here is equal to 0. All right. Does anyone have questions right now that they even know how to express? Do you have a pencil? All right. Check your solution. I'm not going to do that right now. We need some more time. Let's go on to the next one. Solve the following equations. We're going to solve them by factoring. What's the first step? GCF. Always look for a GCF first. So I have 5x squared minus 25x. What's my GCF? What can I divide both of those terms by? Give me 5. How about 5? Can I divide by 5? Yeah. How about an x? They both have x. How many? X to the first, x to the second. X to the first. All right, you just found your GCF. So that gets factored out in front with the parenthesis next because we're not just finding the GCF, we are factoring. So 5 divided by 5 simplifies to 1. X squared divided by an x. We subtract the exponents. We only have an x to the first left. Minus 25 divided by 5 is going to be 5. And x divided by x simplifies out to be 1. Equals 0. Come on. Okay? So I'm going to put this like this to help me remember each of these could equal 0. So we say the first term, 5x is equal to 0. And x minus 5 is equal to 0. So to solve for x, divide by 5, divide by 5. X is equal to 0. Over here, add 5. Come on. Add 5. 5's cancel out. X is equal to 5. So when x is equal to 5 and I substitute it back in here, that makes that factor 0. So yes, anything times 0 is 0. When I factor or put this 0, not factor, back in for that second factor, I get 0. So 0 times anything is 0. So that works too. So x is equal to 0, which would make the first factor equal to 0, or x can be equal to 5, which makes my second factor equal to 0. Questions on that? Okay. Ooh. See if you can do letter B on your own. Remember, what's my first step since we're doing this? We're solving by factoring. I need to look for a GCF. If I can write it. While you're doing that, I should take attendance. Whew. No Tristan. Lauren, Caden. No Marie, Nick. Jeremiah. I don't think he's here. Diana, Renaya. No Christiana. Louise, Desmond, Charles, Rihanna, Camille, Jamarian. All right. Let's see. Did you find the greatest common factor? You guys are so quiet. This is a 1. Can I factor out a 1? Sort of. You could factor out a 1, but I'm really interested in the x's. I can factor out an x to the first, right? And 1 times x is x, so we'll just put x out here. Times, what do I have left? 1 divided by 1 simplifies out. X squared divided by x is x, right? That's an x to the first. 2 minus 1 leaves x to the first. Minus, cheap apple dupe. 12 divided by 1 is 12. And x divided by x simplifies out to be a 1. So those are my two factors. I'm going to set up this t. Well, this is going to be equal to 0. When x is equal to 0, there's no work to do there. And when x minus 12 is equal to 0. So add 12, add 12. 12's cancel out. X is equal to 12. Anybody have either of those or both? Not yet? So your answer, x is equal to 0 or x can be equal to 12. Okay? By factoring a trinomial. Let me see where we're at here. Oh, yeah, we need to keep going. All right. So now we're doing this with a trinomial. Example number 4. Still follow those same steps, right? So ask yourself, self, do I have a greatest common factor? Well, if you have a 1 out in front of a trinomial, the answer is no. So then you need to do X box again. So A is equal to 1, B is equal to -2, C is equal to -8. So for the top, think of the rainbow. We have 1 times -8 is -8. B is -2. Two factors of 8 that add to give you -2. And the larger number is negative. So these are going to be negative because they're larger. Okay, well, there I see it. It's 2 and -4. All right, so there are your two helpful part of the factors. We are going to have x plus 2 times x minus 4 equals 0. Okay, so this time I'm splitting this t over here. Set each factor equal to 0. X plus 2 equals 0. We subtract 2, x is equal to -2. So when x is equal to -2, that's going to make that first factor equal to 0. That's how it zeroes out, right, Charles? Charles, come on. X minus 4 equals 0. Add 4. So this factor is going to be 0 when x is equal to 4. Because if I substitute it in, that gives me 0. So final answer, x is equal to -2 or x is equal to 4. Questions on that? You're just setting each of these factors equal to 0. Why are we doing that? Because again, if your answer is equal to 0, and after you factor it, one of these or both has to be 0. So you set the one factor equal to 0 and solve, set the other factor equal to 0 and solve. All right, last part. Use the roots to sketch the graph. Okay, what were my roots here? The roots were x equals -2 and x equals 4. So let's put that, x equals -2 or x is equal to 4. Those are your roots. So if I'm counting these units by 1, here's 1, -1, -3. So x equals -2 is right there. X equals 4 is right here. So your x-intercepts are -2 and 4. Axis of symmetry. Do you remember how to find the axis of symmetry? X equals the opposite of B, all divided by 2A. Hopefully, is yours on the same side? Opposite of B. B is -2. So the opposite of -2 is a +2 divided by 2 times, what was my A value here? 1. So that's 2 divided by 2. So A is equal to 1. So at A equals 1, let's do a nice big dashed line. Your axis of symmetry. X equals 1. Says because A is positive, the graph opens what? Up or down? Up. Okay, it was A is equal to 1. The y-intercept, if you remember, is your C value. My C value here is -8. The C value is equal to the y-intercept. So on the y-axis, let's find -8. 1, 2, 3, 4, 5, 6, 7, 8. We know it's opening up. So here is your parabola. So homework number 2. You can now begin homework number 2. But homework number 1, you need to be working on that and getting that finished, okay? All right.